one of the key challenges is, well, I have my institutional clients group with institutional clients here, and I have my commercial banking with small, medium enterprises, and then I have my consumer banking here. Well, guess what? The data's in silo, it obviously, right? As one would expect from a big bank. So one of the huge opportunities that we identified was, okay, so how can I leverage what I know about how my customers, my consumers spend, in order to better inform my traders? Or can I integrate risk and then have a better vision into the riskiness of a small business because they trade a lot with a big business? So that bringing those silos together and breaking those walls from a data perspective, that was the initial motivation for us to develop what we have developed and keep expanding on it. Well, there are things that we are doing today, but it just is taking too long, so we can do it much faster. And there's value attached to that. One example is, we were trying to do some, name matching to identify prospects. Well, it was taking about 18 hours just to run a small sample, and we moved it over to the Hadoop environment. Well, guess what? It took 14 minutes. That's something.
The two major drivers for smart data, notice I was careful to use the term, are doing data analytics, being able to get insights that you were not capable of doing before, and then there's also the time dimension on that. So while you may have been able to get some of these answers, they might have required a development effort, and by the time you got the information, it wasn't useful anymore. So the two major drivers are the data analytics and also greater, and it's related to that, is greater insight into what's happening in the business. The nature of some of these technologies is you can start small and maybe merge two data sources where the groups are already cooperating and demonstrate the value from that. Because of the flexibility, the investment that you make in the first two is still there as you add the third, the fourth. So it's one of the points that I was making about this not being a disruptive technology. You can start with a small project, demonstrate the value of it, and then build and add to it.
I think there's a dramatic change in the cost equation coming out of the technologies in the big data bucket. Right? So all this time, over the last 15 or 20 years, we've been in straitjackets based on cost. The cost of processing information is so high, so much data, there's so much to process, and the way we do it is not efficient. It keeps the costs high and therefore prevents us from anything. Big data essentially frees us from those costs. For the last 20 years, we've been using these relational models to describe our business. Right? And these are very poor abstractions of the business world. We do not accurately represent the way business evolves, the way business is done in our data models. So there's a need for better representation of the underlying data. So if we look at representational models, we see that these new NoSQL databases are much better representations. The new semantic databases, the new graph databases. These are jumps in innovation that allow us to represent reality much better. That's things that we've learned the hard way over the last 20 years. Quality, absolutely critical. Measurement of quality and metrics in the big data space is going to be critical. Right? Second is, in terms of, we've talked about this as well, the veracity of the models. Unless we have the glue to put all this together, and that we have these uber models that describe the big data world, and we govern that. So governance of these new models for big data. Again, you need that set of capabilities. And then, of course, governance in terms of the reporting space and the visualization space as well, because that's where the value is being generated. So supporting reporting and visualization.
What it gets to is what we're seeing now a significant number of our customers doing is using Hadoop as, and what I heard, the term I like, one of our customers called it data reservoir, where they're storing all this data, like I said before, of, it's a catalog essentially of data. So later when I need it, when I have this unknown problem and it leads, the data scientists are led down an unknown path, they know where that data is going to be, and they can run a batch job. So we have customers in the life sciences space that are generating now with kind of sensors and testing equipment on the whole. It used to be they maybe used to do like 100 tests. Now they do the whole human genome, so it's 100 million kind of columns of data, essentially. It takes them 12 hours to run a batch job with Hadoop. Probably would have taken them 12 years to do, a couple years ago, without this. Then they do a lot of processing in R. But then at the end of the 12 hours, and even this probably takes a couple hours, is they load it into Teradata, warehouse.
But we always know what happened. Through our transaction reporting systems and analysis, we know what happened. We sometimes know why. So we know that yesterday 4,000 new accounts were opened by this client. 1,500 of them were electronically opened on the web. 5 of them were abandoned, but we don't know why. So we always know what happened. What we sometimes know is why. Somebody did a withdrawal from a 529 plan, pretty sure you can understand why that was. But if someone had a series of small withdrawals from their account, not exactly sure what's going on there. And we almost never know what's going to happen next. So when we look at progressing from descriptive analytics, which is a little bit of hindsight, to diagnostic, which is a little more of insight, to predictive, which has a little more foresight, the ability to take semantic data and coalesce it with everything else is going to let us help make those decisions better.